So welcome back to my channel, Training Solutions. Today I'll be talking about organic pharmaceutical chemistry. I'll briefly be explaining organic chemistry in different presentations. However, I won't be explaining the mechanism of reaction because of presentation issues. What is organic chemistry? Organic chemistry is the study of carbon compounds. Of course, they usually contain hydrogen or even other atoms such as oxygen, nitrogen, and sulfur. Of course, these are what we call the heterocycles. Now, the catenation property and tetravalent property of carbon enables it to form diverse compounds. So what is catenation? Of course, catenation occurs when atoms of the same element covalently bond to one another to form chain or ring, as shown in carbon. Now, what's tetravalence? Of course, tetravalence is all about forming what? Forming 4 unpaired electrons which are available for bonding. And in carbon, it has the electron configuration of 1s2, 2s2, and 2p2. These ones you know, of course. And in excited state, one electron in the s2s jumps to what? Jumps to the p2 as shown below. And once they jump, it forms 4 unpaired electrons. Those are the ones which are available for bonding. So the atomic orbitals. Of course, we know these are atomic orbitals. This is an area around the nucleus where we may find electrons. We have s orbital, which contains 2 electrons. P, 6, D, 10, and F can contain up to 14. Now, what is the Hans rule during the filling of these orbitals? Of course, when assigning electrons in an orbital, each electron will fill first all the orbitals with similar energy before pairing with other electron. Now, hybridization. Now, of course, the concept of hybridization is involved mixing 2 atomic orbitals with the same energy levels to give new degenerate or the hybrid orbitals with different shape and energies, of course. That's a repetition with shapes and shapes. Classified as sp3, sp2, and sp. Now, with sp2, it involves mixing 1s orbital with 2 p orbitals, this one of equal energy to give the new hybrid orbitals. Like this one results in formation of a double bond as shown in ethene. So now in the sp hybridization, 2s orbital is mixed with only one of the 3 p orbitals, resulting in 2 hybrid sp orbitals having linear structure with a bond angle of around 180 degrees, and the remaining 2 orbitals also bond to form the pi bonds. This is what forms the sp, and then this is the pp. This is what forms the triple bond. It is common in ethane and the beryllium compounds. Now, in explicit hybridization, as shown initially, the 4 unpaired electrons combine with the 1s hydrogen to form the tetrahedral hybridization, tetrahedral structure, the ethane, this one. So we're having the 4 hybrid unpaired electrons which have been formed earlier, and then so they combine with 1s, 1H, 1H, forming tetrahedron structure like in methane and all alkane compounds. Now, what is isomerism? Isomerism, of course, this is a phenomenon where 2 or more compounds having the same molecular formula, but they differ in spatial arrangement of chemical atoms. And of course, the chemical and the physical properties also will differ. And of course, isomers are these compounds which are formed. There are 2 types of isomers. We have structural and stereoisomers. Now, these ones I know you know them. Chain, we have chain isomerism, position isomerism, function isomerism. Of course, in function, we're having the functional group changing structure, changing position. Metamerism, tautomerism, and of course in ring structure. We also have the stereoisomerism or stereoisomers. We are having the geometrical and the optical. Now, let me talk about bond diffusion. Of course, in the bond diffusion, this is the one that kickstarts the mechanism of reaction. Of course, bond diffusion is when the atoms, remember in hybridization, it has formed a bond, but now here in diffusion, the bond is breaking. We have hemolytic. This happens if the bond breaks in such a fashion that each atom gets one electron of the shared pair electrons. However, in heterolytic, one electron pair takes all the electrons, forming, of course, charged species. This has been just a simple presentation about introduction to organic chemistry. These are other presentations which are following. You can search about them. Thank you for listening to me and watching the video. I remain Wilson, and subscribe to our channel, Pharma Training Solutions. Contact us on those email, like the video, or you can send us a comment on how we can improve. Thank you very much.